Hello everyone, I am Vijaya Gadade from Department of Computer Science. Today we are seeing the concept of the algorithm. So first concept is what is algorithm? An algorithm is a finite collection of well-defined steps designed to solve a particular problem. It is also defined as an algorithm is a step-by-step procedure or execution for a particular problem. To solve a particular problem, we have to follow some of the steps. An algorithm takes a set of values as input, produce a value or a set of values as output. For solving algorithm, we can take values as input, produce them and produces an output. Okay, next one is what is algorithm. The diagrammatic representation are seen here. On the left hand side we have the input or data or items problem that needs to be solved. In the middle, algorithm is shown in the diamond shape, which means a set of rules or step by step instruction used to process the input. For example, whatever the input we have taken, that will be taken in the input values or instruction values, and we can produce that values or process them that values into the output. On the right hand side we have the output, which is the result obtained after applying the algorithm to the input. After applying the input to the algorithm, we have to maintain our output. Okay, next step is that is characteristic of an algorithm. So basically there are 5 characteristic of an algorithms. So first one is input. An algorithm must take 0 or more input that are required for solution of a problem. For solving a particular problem, we have to take the input. Okay, next one is process. An algorithm must perform a certain operations on the input data, that we have taken the input, we can process them, and which will produce an output. An algorithm should produce certain output after processing the input. After processing the input, the output will be produced. Next one is finiteness. An algorithm must terminate after executing certain finite number of steps. The algorithm should be follow some of the procedure, and that is nothing but the finiteness. Next one is effectiveness. An algorithm should be simple and clear. Each steps in the algorithm must be ambiguous and feasible and definite. Algorithm is should be in a simple format. These are the characteristic of an algorithms. Next one is time of complexity. So the time complexity can be divided into, first one is time complexity and second one is the space complexity. So we will see the time complexity. Time complexity of an algorithm is the amount of time or the number of steps needed by a program to complete its task. For example, the time complexity can be measured in the 2 ways, that is compilation time and runtime. Compilation time is the time taken to compile an algorithm. For example, for solving or for completing the task, we will take a compilation time. While compiling, it will check for syntax semantics error in the program and link with the standard libraries. The example of compile time is the nothing but the syntax and semantics errors. Okay, next one is runtime. It is the time to execute the compiled program. The runtime of an algorithm depends upon the number of instruction present in the algorithm. The basically runtime algorithm is the execution of the compiled program, and it will take a number of instruction to complete its task, is nothing but the runtime algorithm. Next one is space complexity. Space complexity of an algorithm is the amount of memory consumed by the algorithm until it completes its execution. Space complexity is nothing but the space required to process or space required to fill the algorithm. A fixed amount of memory occupied by the space of for the program, that is the data types, code and space occupied by the variable used in the program. Okay, for example, the variable which we are using is having a required minimum number of space. So the variable amount of memory occupied by the component variable whose size is dependent of the problem being solved, and this space increases or decreases depending upon the whether the program is iterative or recursive procedure. For example, recursive is nothing but we can define a function or we can define a program, and we can repeatedly use that function in the program. This is nothing but the recursive call. And next one is types of space complexity. So there are 2 types of space complexity. First one is fixed part and second one is variable part. In a fixed part, part, that is a space required to store certain data and variable that are independent of the size of the problem. Okay, example is simple variable and constant use program size. The amount of variable, for example, integer, for storing integer variable we can store a two bits, and yes, and so on. So this is nothing but the fixed part, and the variable part is nothing but a variable part is a space required by variable whose size depends on the size of the problem. That is, example is dynamic memory allocation and recursion and stack space, etc. These are the examples of variable part type space complexity. Next one is types of analysis. Okay, so there are three types of analysis. First one is worst case type analysis, second one is best case, and third one is average case. So if the running time of an algorithm is the longest for all the input, then it is called as worst case. If the algorithm takes a longer time to execute, then it is called as worst case time complexity. In this type, the key operation are executed maximum number of times. Okay, the steps are followed by a very long period of time, and then this is called as worst case time complexity. Next one is best case. If the running time of an algorithm is the shortest for all the inputs, then it is called as best case. The algorithm takes the minimum number of time. This is nothing but the base case time complexity. In this type, the key operations are executed minimum number of times. The steps or steps that are executed algorithm is the minimum, so this is called as base case time complexity. Next one is average case. If the running time of an algorithm fall between the worst case and best case, then it is called as average case. Okay, next one is to calculate the average time complexity, we have to take a sum of the assumption and selecting for an algorithm. It will take us unsorted array of length n. So if we find the element in the first position, then it is called as base case. For we are taking an array list, for example the length is n, and the element is found at the first position, then it will called as the base case time complexity. If the element is found at the middle of the position, then it will called as average case, and if the element is found at the last, so it is called as worst case time complexity. So the type of analysis can be divided into three types, that is worst case, best case, and average case. Next part is linked list. A linked list is a type of linear data structure similar to arrays. It is a collection of nodes that are linked to each other. A node contains two things. First is data. Second link is that connects to the other node. This is the diagrammatic representation, that is A connected to B, B connected to C, and so on. So the first A is nothing but the head of the linked list, and D is pointing to the null pointer. So first node is divided into two parts. That is, first part is data, where actual data is present, and next part is divided that will contain the address of the next node. This is nothing but the linked list. Next one is type of linked list. So first one is singly linked list. The node contains pointer to the next node, means the node store the address of the next node in the sequence. A single linked list allow the travels of data only in one direction. In a single linked list, we can traverse the data, or we can traverse the linked list in only one direction. Next one is doubly linked list. A doubly linked list or a two-way linked list is a more complex type of linked list that contains pointer to the next node as well as the previous node. It is a traverse in both direction, that is backward direction as well as forward direction. Okay, here the data the node is divided into three parts, that is the first previous node, backward direction node, and the actual data. Okay, so A contains the actual data, it will connect to the next node also and the previous node also, and all the nodes are connected to each other. This is nothing but the doubly linked list. Next one is circular linked list. A circular linked list is a type of linked list in which last node next pointers to the back to the first node and the list, creating a circular structure. This design allows a continuous traversal of the list, as there is a no null into the list. That is, first node is connected to the last node and it will form a circular data structure. Next one is doubly circular linked list. A doubly circular linked list or a circular two-way linked list is a complex type of linked list that contains a pointer to the next as well as the previous node in the sequence, and the circular doubly linked list does not contain a null value because the two nodes are connected to each other, and this will form a doubly circular linked list. Thank you all.